name is Sergii, and I'll talk about building a Git server in Go. And we'll also learn how Git clone operation works, and I will try to build a simple Git server in 7 minutes or less. So there's this great library called gliderlabs SSH, which makes it easy to build any kinds of SSH servers. And we can use that to build a Git server as well. So a little bit about me. My name is Sergii, and I'm an infrastructure engineer at Axios Media. But as a side project, I'm also building this service, Git Patch, that is Git, kind of like a Git hosting service that lets you exchange patches. So here's the basic SSH server that just prints any command that the client runs. And so what happens if we run git clone on it? So here's the output. It's running git-upload-pack command with the /demo argument. That's the argument that we pass when we run the git clone. And if we look at the documentation, this is the docs for this command. Git-upload-pack is an internal command that sends objects to the client. So objects are commits, tags, trees, which is directories, and blobs, which are files. And so let's try to implement something like this. First, to serve our repository, we need to read the unadvertised references. In this case, we are reading the main reference and then writing some packets in the format that protocol expects. But this is a regular output to the client. And if we run that with the special environment variable git trace packet, we'll see our packets, and we can see as well that Git sent us a couple of want lines, which means that Git is requesting these objects. So let's see how Git stores data. It's pretty much a database. There is an index file in IDX, which stores object hashes. And then there is a pack file, which stores the objects themselves. And the rev we can ignore for now. So this is the structure of IDX file. First, there is a header. Then there is a table of an object counts. And then we have a sorted list of object hashes. And at the end, there's a list of offsets or locations of these objects in the pack file. So let's implement some code. Here's the index iterator that returns a list of hashes and object structs and yields them as a output of this function. So it's a lot of code, but all it does is read in the index file and gives us the objects. So here's what happens if we run it. It's a range over function call, and then we get a list of hashes in our repository and the locations where they are stored. Here's the structure of a pack file that stores the actual objects. At the top, we have a header and then all the objects themselves. And at the end, there is a SHA-1 checksum of the entire file. And this pack file is used for both storage on disk and for the transfer of the objects. So this is the file that we're going to write out to the client. And here's some code that does it. I'm using here a multi-writer to write the data to the client and to the SHA-1 function so I can compute the hash. And then for each pack object, I'm calling them, for each pack file, I'm calling the write objects function to write the objects. And here's how it looks. So I'm sorting objects to return them in the right order. And then I'm creating a section reader. And so I'm reading only the specific part of the file. And buff.io reader robs it to read the file in chunks. And also because the objects are stored in a compressed form, I'm piping them into zlib and also using treader to also write them to the client as I'm reading them. And the last step, I'm discarding the actual decompressed form of these objects because I'm not using them. But I still have to call them because I need to run the reader. And here, what happens if we try to run this? It doesn't work. So what's the issue here? So the issue is that zlib expects to read data as bytes one at a time, which means it needs a read byte function. But treader doesn't implement it. So that causes that causes the zlib to allocate an internal buffer.io reader and buffer the data. And that makes it read more data than necessary. So the solution is to replace the treader with the custom tbyte reader that implements both read and read byte functions. If we do that, make that change, now we can clone the repository. We got all the objects and we can confirm that all the files are there. So overall, this is about 300 lines of code. And the full source is on GitHub. You can check it out. That's all. Thank you.